right, this is lesson 8.1, task 1. Describe a piecewise defined function. A piecewise defined function is a function that has different rules for different intervals of its domain. These intervals must be distinct because a function cannot produce two different f of x values for the same x value. A deep farmhouse sink is slowly being filled with water at a rate of 2 gallons per minute. After 4 minutes, the stopper accidentally comes loose, and over the next 2 minutes, the volume decreases by 15 quarts. Once the stopper is properly put back in, water fills the sink at a rate of 3 gallons per minute to fill the sink to a capacity of 22 gallons. Alright, it says after 8 minutes of washing dishes, the stopper is pulled on purpose and the water is completely drained from the sink at an average rate of 8 gallons per minute. Alright, so you can see most of these are in gallons, but there is one spot here where it says it decreases at 15 quarts. So you have to look that there are two different measurements there. Alright, it says explain why the situation can be modeled using a piecewise defined function. Because there's different rules at different points in time. So that's why you would use a piecewise function. A graph modeling the volume of water in the sink is shown. All right, across the bottom, you've got time in minutes. So it goes from 0 up to almost 23 minutes. And the y-axis on this one, it's called V, but this is the y-axis. So this is the volume of water in the sink, and this is in quarts. Remember, above some were in gallons and some were in quarts, and 4 quarts are in 1 gallon. All right, so choose the words that best complete the sentence. The domain of the function is, all right, the domain comes from your x's, so that goes from 0 to almost 23. And the range is your y values, so 0 up to, looks like 22 gallons. And then for which interval is the graph increasing? Select all that apply. All right, we read a graph from left to right. Increasing means it's going up. So this one's increasing, decreasing, increasing, constant. This one's staying the same, and this one's decreasing. So increasing would be A and C. All right, choose the words that best complete the sentence. An increasing interval corresponds to water filling the sink because the volume is increasing over time. For which interval is the graph decreasing? Select all that apply. All right, so it's decreasing. It's going down on interval B and E. So B and E is decreasing. All right, a decreasing interval corresponds to water leaving the sink, draining from the sink. For which interval is the graph constant? Okay, so where is the graph staying the same? That would be interval D. And it says, choose the words that best complete the sentence. A constant interval corresponds to an unchanging water level in the sink because the volume stays the same over time. All right, that's all for task 1. If you have any questions, please let me know. All right, we're going to continue on lesson 8.1. This is task 2. Evaluate piecewise defined functions. You can evaluate a piecewise defined function by substituting values of the domain for the variable in the function rule. When evaluating a piecewise defined function, you need to first determine which piece of the function to use. Consider a relation in which one value in the domain is associated with two different values of the range. For example, look at the mapping diagram here. 0, 3 and 0, 8 would be ordered pairs from that mapping diagram. That would not be a function because 0 goes with two different numbers in the range. All right, so choose the word or phrase to Correctly complete the statement. This relation is not a function because 0, 3, and 0, 8 would have repeating x's, so that's not a function. This is because there exists an input that does not have a unique output. All right, a piecewise defined function is shown below. The three intervals for the domain do not overlap. All right, so it is called a function because it does have unique x values. So that's why the domain cannot overlap. So this says this part here is just representing the domain for these three functions. So we've got three pieces of a function, each defined on this part of the domain. So this one is x less than -3. This one's x between -3 and 2, where 2 is not included. And this one's for all x greater than or equal to 2. So you can see how this one does not have a line under it, which means -3 is not included in the first one. And it does have a line here, so it is included. And then 2 is not included here, but it is included here. And that's why it's a function. All right, so if we want to graph this function, you can see the first one is -2x, and that's for x less than -3. So if you come down here and see -3 is here, and it's got an open circle to show that -3 is not included, but that's what that piece of the line would look like. All right, the next one, 3x plus 1, we're going to graph that line, but we're going to make it a line segment because it's going to be between the domain of -3 and 2. And you can see where this is a closed circle and this is an open circle. That's very important that this represents that the -3 is included here, so that's closed, and the 2 is an open circle because the 2 is not included in this middle piece. And then the third function, the third piece of this function, starts with a domain of 2, so that graph is showed here with a ray as well. And you can see that x greater than or equal to 2 for this line, and that's why it's only the values that are greater than 2. And 2 is included, so that is a closed circle. But you can see with this one open and this one closed, it still passes the vertical line test. And again here, this one's open and this one's closed, so it still passes the vertical line test, so this piecewise function is a function. All right, match each piece of the graph with the equation that defines it on the appropriate interval. All right, so the left piece goes with x less than -3. The left piece is -2x. All right, the middle piece, that's the middle piece from -3 to 2. That's 3x plus 1. That's this piece here. And the last piece is the last function here, x minus 1 for all x is greater than 2. So that's this ray here. So all you're doing is defining each part of the graph with the function that it goes with. All right, choose the word or phrase that best completes each statement. The left piece of the graph is it's a ray because it has an arrow on one end. The middle piece of the graph is a line segment because it's got either an open or a closed circle. And this one is a ray as well. So you can see the ray has an arrow. This ray has an arrow. And this one is a line segment because it does not have an arrow on each end. All right, it says explain how each piece of the graph relates to the domain intervals. All right, so each piece of the graph has to stay within those x values, which make up the domain. All right, it says choose the words or numbers to complete the statements explaining how to find values of this function, which is defined on 3 intervals. All right, so the number -3 is part of which interval? So this says all x is less than -3, but it doesn't include -3. Here, x is greater than or equal to -3. So the equal means it's part of the middle or the second one. Therefore, f of negative 3 is, all right, all we're looking at is the middle function, 3 times x plus 1. So 3 times negative 3, 3 times negative 3 is negative 9. Negative 9 plus 1 is negative 8. So when you're trying to evaluate the number, you don't worry about the domain. The domain just tells you which function to choose to plug this number into. All right, choose the words or numbers to complete the statements explaining how to find values of this function, which is defined on 3 intervals. All right, the number 0 is part of which interval? All right, x less than negative 3. X is between negative 3 and 2, so 0 is between negative 3 and 2, so we're going to look at the middle interval. So that's the second interval. Therefore, f of 0 is, all right, if I plug a 0 in, 3 times 0 is 0, plus 1 is 1. And then the number 2 is part of which interval? 2 is not included in the middle one. And this one says x greater than or equal to 2. So 2 will go for the third interval. And if we plug in 2, we simply plug 2 in for x. 2 minus 1 is 1. All right, if you have any questions about task 2, please let me know.